Hello everyone. In today's Yahoo demo, we are going to be looking at a workflow that integrates with ServiceNow, Splunk, Slack, and GCP, the Google Cloud Platform. In this demonstration, Splunk will be picking up on a disk whose space is quickly filling up. The disk belongs to a virtual machine in GCP. And when those events reach a certain threshold and generate that Splunk alert, Yahoo is going to pick up on the alert in real time, trigger the workflow that we have up right here. It's going to parse all of that event data out of the Splunk alert, and it's going to reach out to our admin in Slack and give them the ability in real time to dynamically resize the disk on the GCP VM. We have the disk filling up in the background right now. If we head to our Audit Trail section, we will quickly see the alert be received from Splunk in just a moment. And there we are. Here's our alert coming from Splunk in real time. Now let's pull up my Slack window so we can wait for the exact moment that we receive this message. In the execution log behind me, we can see that the workflow is currently pulling all of the event information associated with this particular alert so that it can then parse out that event data and figure out what this alert is for, the affected host, etc. Once it figures that out, it's going to reach out to the CMDB in ServiceNow to determine who the owner of this machine is, figure out his Slack ID, and then send him a message, which you can see happened right here. So we see that a Yahoo NG has received a Splunk alert for high disk space utilization. We've got a link to our ServiceNow ticket, a link to our Splunk alert, and then some other information, the affected host, the OS build, the current disk size, and also the usage percentage. And that gives us an option here. Do we want to increase our disk size? Sure. Let's go ahead. We can see as the clicks I give here in the conversation are recorded in real time behind me in the log. It's now going to give me some pre-configured resizing options. I will choose a custom option for today's demonstration. Let's just increase by 1 GB. Now, with our new integration into the Google Cloud Platform, we are actually powering off this VM, waiting for the exact moment that the VM has gracefully and fully powered off. At that time, we're going to take the virtual disk, we are going to add space to it according to the conversation here and what the admin, who today is me, answered. And then once that's been done, we're going to update our ticket and report back here in Slack, which you can see happened just a moment ago. All right, so let's click on our ServiceNow ticket. Here in our ticket, we can see the configuration item was automatically populated here, referencing the CMDB in my ServiceNow instance. We've also got a short description saying that a Yahoo NG has received a Splunk alert for high disk space utilization. And the same information we saw in our Slack message is right here. A link to the Splunk alert, the affected host, the OS build, current disk size, and usage percentage. Down in the work notes, we can see step by step everything that a Yahoo did. Reaching out to the admin via Slack to present resolution options, recording here that the admin chose to add space to the affected disk, and then finally, the C drive on instance 2, that's our host name, was successfully resized from 64 to 65 gigabytes. And then, of course, the ticket was resolved. If I go over into my GCP instance here, here's instance 2, still being powered off. And if we go over to our disks, we can see instance 2, 65 gigabyte disk. Now, going back to the Yahoo NG side, just so we can take a quick glimpse here in the audit trail where we were a minute ago, when these events come in from external systems, whether they be a monitoring tool like Splunk or SolarWinds or Logic Monitor, or whether they be an ITSM tool like Sharewell, ServiceNow, BMC RemedyForce. Those events are ingested in real time into the Yahoo platform, and if you see here, all of the fields from that event, so in this case, all of the fields associated with the Splunk alert, are all pre-parsed for me. So I'm very easily able to set up very specific or broad trigger conditions to execute the exact workflow that I need. And I'm also able to, of course, reference any of these fields as variables within that workflow itself. Closing this and opening our menu and going back to where we started in the Workflow Designer, let's take a quick look at the workflow that made this automation possible today. Well, to start things off, we are going to retrieve all of those alert events associated with the particular SID of the Splunk alert. We're even filtering with a time frame here. This is customizable. It's just, in our use case, we're really only concerned with alert events generated in the last 5 minutes for this particular alert. And once we do that, well, we parse out the event data, ultimately giving us the host name for the GCP instance, the affected volume or disk, and then we use our GCP activity here to actually dynamically pull disk information on that particular host. After we do that, we of course determine how much is being used presently on that host. We also pull the OS build, as you saw, and then using our very robust and extremely simple ServiceNow integration, we can say, I want to get all records from the Windows Server CMDB table where the name is equal to the host name. This will effectively give us the complete CMDB entry for this particular host. After we have that, well, extracting the Slack ID is simple. Creating our ServiceNow ticket with all of the information you saw just a few moments ago in my browser, also very simple. And then starting a conversation in Slack and reaching out to our admin is, again, simple and visual. When we're building these workflows, we're only designing and customizing. It's not even development. That's how simple it is to use a Yahoo. Presenting buttons as options here, as simple and visual as you see right here. And then, of course, intelligently taking different paths throughout the workflow based on input is happening as well. Down our right branch, well, this is what happens if the admin chooses to ignore the alert. But in today's example, we traveled down this left branch here, where we update our ticket with work notes. If you recall, we said that the admin chose to add space. We send a message back saying that, we're getting to work, please stand by. And then coming down here, this is where we again use our GCP activities to turn the instance off. We retrieve the current state of the instance. And then with this neat little trick here, we are able to actually continuously check on the state of the instance by traveling down here, left branch, and back up again over and over, pausing 5 seconds in between, as you can see, so that the exact moment that the VM is powered off cleanly, we can get to work with the disk resizing, which of course happens right here. So resizing the disk is just as easy as specifying the name and of course the new target size, which I calculated a few steps earlier in the workflow by taking the current disk size and then adding to it the input received by the admin, which if you recall today, I chose to add 1 gigabyte. After doing that, if the disk resizing is successful, which it was today, we will update our ticket and then of course send a message back to the admin in Slack. If for any reason there should be some sort of problem, let's say there's some sort of licensing issue or really any number of other things that could possibly go wrong with your cloud infrastructure, whatever the case may be, the verbose error is captured here by this activity, inserted into the ServiceNow ticket, and also returned to the user in Slack. After all is said and done, we send a final goodbye, and we terminate the conversation. And just like that, automating remediation of all different types of cloud infrastructure alerts, like today's example with disk space utilization, is as simple as the workflow that I just gave you a tour through right now.